Hello, we are Team 3. Building is the shard. Last week, we talked about constructional constraint, top-down construction, foundation. The constructional constraint of the shard in three parts: time, geographic, and urban prospect. The shard had a time constraint. They had to construct the shard and list in 3 years. London clay is highly susceptible to volumetric changes depending upon its moisture contact, which can occur many problems, like movement of structural movement and fracturing of the building. London Bridge and London Street are adjacent, and there are many nearby buildings. So we had to pay attention to rapid construction and building subsidence prevention. Top-down construction. The concept of the top-down construction is construct above floor, below floor simultaneously. Foundation. The left and piers supporting the left served as the foundation of the shard building. In the shard construction, the left below the core and elsewhere thickness is different, and main bearing piers and elsewhere diameters has difference. This optimized left and pier minimized the amount of excavation and material used. For this week, we talk about ground, left, and pier. Ground. The shard ground layer is consist of alluvium, river terrace gravel, London clay, Lambeth group, sand sand. Let's start with the characteristic of London clay. Typical unweathered London clay is a form to very steep, fissure, dark gray, or blue-gray silty clay. Due to silty clay's property, London clay has much void water, which causes volume change of the soil. When the persistent water deficit develops as a result of leaks from water supply pipes or drains, subsidence of the building can be occurred due to shrinkage of the soil. When the persistent water deficit dissipates or void water is increased by heavy rain, half of the building can be occurred due to swelling of the soil. Damage to buildings may occur when the volume change of the soil, due to shrinking or swelling, is unevenly distributed beneath the foundations. For preventing volume change of the soil, the shard construction team used secant wall to cut off the vein of groundwater and prevent movement of the soil. And there is a part underneath the shard's ground layer, divided east and west. The bird make East Lambeth Group's elevation of top of strata 5 meters lower than west. So longer piers were required on the east side of the site. This is a borehole's pressure meter limit, pressure B elevation graph. Focus on Sanderson layer, the expected decrease in limit pressure through lower elevation. Now we will talk about left. A foundation is needed to withstand the building's load, and the shard used the pier left foundation. Pier left foundation is a type of pier inserted into an existing left foundation. Although the left distributes the load, the pier left foundation can withstand more load with friction with the ground. It can also transfer load to hard strata beneath the soil. It can also withstand shear loads such as wind and earthquakes better through piers. This is 4-step in top-down construction. It's poured to the second basement floor and supports the core with a slab on the second basement floor. And on the third basement floor, we are installing a raft. Just below the core, which is expected to have a lot of load on the raft, was planned to be 3 meters and the rest 1.5 meters. 1,000 tons of steel rebars are installed to reinforce the raft. Pour concrete for 36 hours after the rebar work is finished. As time goes by, moisture evaporation begins in the surface area of concrete, and the volume becomes smaller. This is called dry shrinkage, which results in tensile stress in the surface area and cracks in the surface area. To solve the crack, the shard used ZZBS concrete. This has low hydration, as this mix doesn't attain full strength until 56 days, compared to 28 days during which the concrete will attain full strength. The ready mix was further modified to make sure that enough strength was available at 40 days for work to proceed core construction. For the equal hardening of the concrete, they had to pour in concrete continuous. For this huge left concrete scale, 4 pumps, 44 wagons at peak were used, and 36-hour continuous pouring was done, which amount of daily used to general building. During this, 700 of concrete mixer was used. Next, pile. The shard is located just beside London Bridge Station. This is the infrastructure beside site of the shard. First, London Bridge Station. London Bridge Station built at 1893. It has an arch structure, and the depth of arch is 3.2 meter. So, why this arch structure was important to construction of the shard? Because the arch structure and construction of the shard was too close. An arch structure was built long time ago, so it could be collapsed by construction. So the engineers have to calculate the effect of construction. The constructors did 3D finite element analysis. Therefore, they could predict the movement of the structure. This is the result of analysis of movement of the structure by construction. After the constructors monitored the movement of arch structure, when movements were more than halfway through the slight damage range, amber alarm would be triggered and red alarm triggered when movement reached the lower and end of moderate to severe damage range. When constructors excavate the foundation, soil beside the site is pressured, so the collapse of soil can occur. To block this situation, secant pile wall is needed. The first step of foundation was installing secant pile walls for the fracture of the construction impact and to prevent sink of water. This is figure of secant pile wall. To make secant pile wall, First, set the guide wall. First, set the universal form. Next, set the panel. Next, set the steel bar to reinforce concrete. Next, pour concrete to make guide wall. Next, make second pile wall.
The piling rig drills straight through the forms to achieve accurate placement. The primary piles are drilled out with alternate spacing to form the intersecting design required for a secant wall. The piles are then filled with the first of two different concrete mixes. The secondary or male piles are now drilled out. This action creates the important interlocking overlap between the piles. For reinforcement, a prefabricated steel cage is lowered into each secondary pile. A second hard concrete mix is then used to complete the wall. Some specifications require all piles to be made of the harder concrete.
After finished construction of second pile wall, constructors started piling for the building or structure. But there was existing piles of previous buildings. Constructors could not remove them because of time and money. All of that circles are existing piles. So constructors just neglected them. They used rotary board piling method. This piling method has advantage that has minimal ground disturbance, which means limited risk of damage to adjacent structures. First, excavate the source to make piles. Second, insert steel cage. Lastly, pour concrete to make piles. Thank you for listening. We are Team 3, building the shard. Our team member is this, and this is the resources. Thank you.